Hello everyone. This video will show how to solve exponential equations involving Euler's number E using substitution. Looking at the example we have right here, this equation resembles that of a quadratic equation. So let's go ahead and use substitution to solve for x on this. We will let u be equal to the term next to the b here, which is e to the power x. This tells us that our u squared will be the square of e to the power x. So that this would come out e to the power 2x because we're multiplying 2 times x is 2x. Now notice that e to the power 2x is actually this one right here. So we can go ahead and express this given equation that we have here in terms of u. So e to the power 2x is u squared. And then we have a minus 6. And this e to the power x is u. So that is 6u plus 8 equals 0. So we're going to go ahead and factor this out. So we're looking for two numbers such that if we multiply them, it's positive 8. And when we add them, it's negative 6. So these two numbers are negative 4 and negative 2. So what we do next is we will substitute our u value, which is e to the power x, back into this equation. So this equation would come out. From here, we can go ahead and use the zero product property to solve for x. So we're going to go set up e raised to the power x minus 4 equals 0 and e to the power x minus 2 equals 0. So we're going to go ahead and solve for x from here. So we're going to add 4 to both sides. Now we're going to ln both sides, and this is how it's going to look like. Using the power property of logarithm, this x here can be placed as a coefficient of ln. So this is how it's going to look like. Solving for x here, or to have x by itself on the left side, we're going to divide ln e to both sides. Now, please remember that this ln e is equal to 1. I'm going to go ahead and write that up here. So this tells us that ln 4 divided by 1 is ln 4. So this is our first x value. Now we're going to use the other equation here to solve for the other x. So we are going to add 2 to both sides. Now we are going to ln both sides and use the power product property just like how we did it here. Now again, please remember that this ln e is equal to 1. So pretty much the left side here is just x because x times 1 is x. And so the second x is ln of 2. So these are the values of x that will make this equation correct. Now let's have another example. Looking at this example right here, this resembles that of a quadratic equation. So we can assign u for this as and u substitution to solve this. We will let u be the term next to the b here, which is e to the power x plus 1. So this tells us that our u squared then would be e to the power x plus 1 squared, which would come out as e to the power 2 times x plus 1, because this binomial will be multiplied by 2, so that's 2 times x plus 1. If you notice, this resembles this part right here. So this expression right here is u squared, and this expression right here is u. So we can go ahead and rewrite this given expression in terms of u. We're going to use the slide and divide method to factor this out. So we're going to slide this 2 to the 3. Slide means we're going to multiply it. So 2 times 3 is 6. And we're going to factor this out. So the factors of 6 such that if we add them is negative 5 would be negative 3 and negative 2. After we use the slide, we're going to have divide method. So what we do is whatever we slide, that's a 2, we're going to divide it to each of the terms here. So divided by 2, divided by 2. Again, this is the divide part. Looking at this, 2 doesn't work with 3. So that means we're going to slide slide these two back into the front of the u. So the first expression would come out 2u minus 3. And then we have negative 2 divided by 2 is a negative 1. So that is u minus 1. So this is the factored form of this u equation that we have up here. So we go ahead and plug our u back into this expression that we have here, where we define u to be e raised to the power x plus 1. So we're going to use the zero product property to solve this. So we're going to use this first factor equal it to 0 and the second factor equal it to 0. So I'm going to go ahead and write that up here. So we're going to solve the first one here. So we're going to add 3 to both sides. We're going to divide 2 to both sides. So we're left with e to the power x minus 1 on the left side. Now we will ln both sides, and this is how it's going to look like. We will use the power property of logarithm. This x plus 1 is going to go to the front, and this is how the equation is going to look like. Now, please remember that this ln e is equal to 1. So I'm going to write that note up here. So x plus 1 times 1 is just x plus 1. So that we will have x by itself, we're going to subtract 1 to both sides, and we will be left with x on the left side. So this is our first x value. Now let's solve this second equation here, and we will solve for x by itself on the left side. Now we're going to use the power property of logarithm. So this x plus 1 is going to be placed as a coefficient of ln of e. And we also remember that if we get an ln of 1, that is actually equal to 0. I'm going to write that note up here. Again, we remember that ln of e is equal to 1. So we're pretty much left with x plus 1 equals 0. And we can solve for x from there. So these are the two values of x that will make this equation true. So that is how we solve exponential equation involving the Euler's number e using substitution.